Good morning, all of you. Now, today we are going to study about this periodic trends in the modern periodic table. Now, what are periodic trends? We will see now. When the properties of element in a period or a group of the modern periodic table are compared, certain regularity is observed in their variation. Okay, so we will come to know about the some regularity is shown in among the elements. It is called the periodic trend in the modern periodic table. In this standard, we are going to consider the periodic trend in only three properties of elements, and that is in valency, atomic size, size of the atom, and metallic and non-metallic character of element. What is metallic? Metallic means that, for example, if you consider sodium, so sodium has the tendency to give one electron. So you can say that is metal or metallic character to give or electropositivity. And non-metallic character means, for example, chlorine. It takes one electron from sodium. So that is considered to be non-metallic. Taking that is non-metallic characteristics. Okay. Now valency. You have learned in the previous standard that the valency of an element is determined by the number of electrons present in the outermost shell of its atom. That is the valence electron. So as we know that the number of electrons present in the outermost shell of any element, that is the valency of that electron. Okay. Now some questions are there. What is the relationship between the electronic configuration of an element and its valency? Okay. So for example, you consider this 2 and 1. So that this is the electronic configuration of lithium. Okay, 3. So we can say that valency is 1. Okay. Now the atomic number of beryllium is 4, while that of oxygen is 8. So write down the electronic configuration of the two and deduce their valency from the same. So to understand this, we will have this chart. Now see here. They are asking about this beryllium, atomic number 4, and the electronic configuration is 2 and 2, and valence is 2. Okay. Then oxygen, the atomic number is of oxygen is 8. Then electronic configuration will be 2 and 6, and the valence will be 2. Okay, got this point? Yes. Now the table on the next page is made on the basis of the modern periodic table. Write in its electronic configuration of the first 20 elements from the symbol and write the valency as shown in a separate box. So you consider this table now. They are asking about this table. They have given, see now, you see in the first block hydrogen. Okay, that first group or one period is there now, started for this first period, second period, third, fourth. Okay, and these are the groups. Okay, so in the first blocks hydrogen is there, atomic number 1, so valency will be 1. Okay, similarly you take in the helium, that now this is the second element of this period 1. Okay, helium, that is atomic number 2, and the valency will be 0. Okay, then come to the second period, lithium, atomic number is 3, so 2 and 1, and valency is 1. Then beryllium, atomic number 4, so I can write 2 and 2 electrons, and valency is 2. So then come to this 13th group. The period is same, but the group is 13. The atomic number is 5, boron, 2 and 3 electronic configuration, and the valency will be 3. Then carbon, atomic number 6, 2 and electronic configuration will be 2 and 4. 4 valency is 4. Then nitrogen, atomic number 7, 2 and 5 electronic configuration. Then valency will be 3. Then oxygen, 2 atomic number is 8. 2 this distribution will be 2 and 6. Valency is 2. Then fluorine, 2 and 7. Valency is 1. Then neon, 2 and 8, and the valency will be 0. So similarly, just you will complete this. Okay, so that 20 elements, the block is 20, so you have to complete this block. Okay, now next is what is the periodic trend in the variation of valency while going from left to right within a period? Explain your answer with reference to period 2 second and period third. So we have to show them the variation of valency, how while going from left to right within a period. Okay, so now you see here we are taken here second period. So we are going from left to right in the periodic table, periodic table. Then you see the first member of second period, lithium. So this I have given this right. I have written this electronic configuration 2 and 1. Okay, then beryllium 2 and 2, boron 2 and 3, carbon 2 and 4, nitrogen 2 and 5, oxygen 2 and 6, fluorine 2 and 7, and neon is 2 and 8. Okay, so this will be the electronic configuration of these elements. So because we know that lithium is having 3 atomic numbers, so 2 and 1, beryllium is having 4 atomic numbers, so 2 and 2. So in this manner it is going on. One electron is increasing. You just see, observe this carefully, and you will find one electron is added in every element. Okay, now come to the third period. In this, these members are there. Sodium is the first member of third period. So electronic configuration is atomic number is 11. So electronic configuration will be 2, 8 and 1. Okay, then magnesium. What is the atomic number of magnesium? That is 12. So we are is 2, 8 and 2. Okay, then aluminium, atomic number is 13. So I will write 2, 8 and 3. And then silicon, atomic number 14, then 2, 8 and 4. So in this manner you go, and the last member of this third period is argon, and that is 18. Atomic number is 18. So I will write 2, 8 and 8. So what do you observe in this? In this you also one electron is added in every element. Okay, and how many shells are there in this? 3 shells are there. Okay, here 2 shells are there. Okay, so this is the specialty. Now, what is the periodic trend in the variation of valency while going down a group? Explain your answer with reference to the group 1, group 2 and group 18. So now we have seen in the first question about the period. Now we will see about the group. Okay, now you see here some members of this group 1 we have taken, that is first. So group 1 you see hydrogen is there. Okay, atomic number 1. So only one electron is there. Then second member is lithium, 3 is there atomic number, so 2 and 1. Then sodium 2, 8 and 1, and potassium 2, 8, 8 and 1. So this is the electronic configuration of this group 1. Then group 2 you see first member is beryllium. You got my point? You see in this here also you see group 1 hydrogen, lithium, sodium in this manner. Okay, and second this group here's beryllium, magnesium. Okay, I have taken from here, and 18 means in this manner helium, neon. Okay, so now you see here beryllium 2 and 2 electronic configuration, magnesium 2, 8 and 2. Okay, and calcium 2, 8, 8 and 2. Okay, then in the group 18 helium is there first member, 2 electronic configuration is 2, neon 2 and 8, and argon 2, 8 and 2, 8, 8 and 2, 8 and 8. Okay, so you see here what is the specialty here. So in the group 1 you see only one electron is there in the outermost shell. Okay, here also you see 1, 1, 1. So what is the specialty in the group? You see for hydrogen is having only one shell. Then lithium you see 2 shells are there, and in the or orbit we can say, and sodium 3 shells are there, 1, 2, 3, and in potassium 4 shells are there, or 4 orbits are there. So as this in the group now, as we are moving from top to bottom now, one shell is going increasing. Okay, similar here also you see here 2 shells are there, or orbit is there, then 3 orbit, 4 orbit. Here you see 2 orbit, no, 1 orbit is there, 1 shell, or 2 shell and 3 shells. So this is the speciality of the group, is that when we move from top to bottom, one shells goes on increasing. Okay, now next is that you see atomic size is given. Okay, next topic, what is atomic size? Now you have seen in the previous standard that size or volume is a fundamental property of a matter. The size of an atom is indicated by its radius. As we know in the generally in radius, as bigger the radius, bigger will be the size of that whatever the atom or this. Okay, so atomic radius is the distance between the nucleus of the atom and its outermost shell. Okay, so bigger the, what is this atomic size? For example, this is the shell, this is the, this distance between the nucleus, this is the nucleus, and this is the outermost outermost shell. Okay, so this is the radius, we can say. Okay, now atomic radius is expressed in the unit picometer. Okay, that is pm, which is smaller than nanometer. Okay, so we know that nanometer is very small, and again in the nanometer it is, picometer is smaller than nanometer. So 1 picometer is equal to 10 raised to minus 12 meter. Okay, now some elements and their atomic radii are given. Okay, radii are given here, elements are given here, and you see atomic radius in picometer is given. Okay, so you see 66, 88, 77, 74, 111, 152. So which is the bigger one here? Atomic radius is bigger of lithium, 152. So this is bigger, or we can say that is the atomic radius of this atom is biggest of this all. Okay, now you will find that atomic radius goes on decreasing while going from left to right within a period. Very interesting. Now you see here how they are telling. You will find that atomic radius goes on decreasing while going from left to right from within a period. The reason behind this is as follows. Okay, so you see here what they are telling, that the atomic radius goes on decreasing when we are moving from left to right. Okay, it is decreasing. What is the, but we know that the atoms, the electrons are increasing, continuously increasing in this, but they are telling that the atomic radius goes on decreasing. You got my point? The atomic, this here, the electrons are increasing here. See here, 19, 20 atomic numbers are increasing. It means the electrons are adding in the same shell. Okay, so we'll see now. So the reason behind this is as follows: while going from left to right within a period, the atomic number increases by one, meaning the positive charge on the nucleus increases by 1 unit at a time. However, the additional electron gets added to the same outermost shell. So what is there in this? That the electrons are adding, but they are adding in the same shells. Shells are not increasing here. Only electrons are increasing or adding in the same shell. So because of this, due to this increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. Okay, so what they are telling, for example, this is the nucleus. Okay, so if the electrons are increasing, no, so they are pulling here. Okay, they are pulled toward the nucleus, and in this manner the atom gets shrink. Okay, becomes small, and because of that the atomic size goes on decreasing. Okay, yeah, some of the elements and the atomic radii are given here. Here also you see some elements are given to you and atomic radius is given. So in this case you see here 262 is the biggest element here. Thank you.